looking at a new topic, and again, a little bit off the script as far as notes go. We'll be using some stuff from the journal, but I'm also adding some of my own notes here just because I want to teach this a little differently than how they present it in the book. So we're talking about altitudes in a right triangle. And so what we're talking about here is basically we're taking a right triangle. So there's my right triangle on the outside. And I'm dropping the altitude from the right angle to the opposite side. So these are also right angles. Now, we automatically, in this case, have similar triangles. 3 similar triangles by angle-angle similarity. Make that C. Usually make a right angle C. Because every triangle in this picture has a right angle. And every triangle in this picture either has angle A or angle B or both of them. And that can be a little tricky to see sometimes. But by angle-angle similarity, all 3 triangles have to be similar. So what we're doing here, essentially, if I pull this out, notice, and I pull this out, oh, it's like magic, isn't it? Okay. We still have a right angle, this is angle A, this angle isn't here, this is a right angle, and this is angle B. So again, we can see our similar triangles. I have a right angle and angle A, right angle and angle A. Here I have a right angle and angle B, here I have a right angle and angle B. So all 3 triangles have to be similar. Both triangles are similar to the large triangle, which means they're similar to each other. Similarity is transitive. Now, the key to solving these problems is redrawing the pictures. And not just redrawing them the way we just did, but let's just go ahead and make this angle C. I will make this B, this A, and we'll call this point D. Okay? So what I'm going to do is I'm going to pull this out. I'm going to clone this. So I got another B here. That's angle B. Okay? This is going to be D. And this is still C. See, the tricky thing to recognize right away is that in this triangle, angle D is the right angle. In the big outer triangle, angle C is the right angle. So the angle C in the big triangle is not the same as the angle C in the small triangle because we're only taking part of angle C. In fact, there are multiple angle C's in this big triangle the way we've got it set up. And that gets tricky. Same here. Whoops. Oh, we can pull the big triangle out. That's fine. Okay. And this is C. Just make it easier. This is B. And this is A. And again, this is my right angle here. There's my right angle. So the right angle is D in this triangle. The right angle is D in this triangle, but it's C in this triangle. The angle C in this triangle is not the same as the angle C in this triangle, is not the same as the angle C in this triangle. That's where things get messy and really hard to work with sometimes. Unless we do this. Reorient all our triangles so they're facing the same way. Then suddenly the similarity gets very simple. Okay? We said the angle C in the big triangle was here. The most acute angle was A, and this was B. But when I broke out and flipped around and did stuff, then angle D in the small triangle was the right angle. And this was C, and this was B. I believe it was, yes. Yep. And then in the medium triangle, angle D was the right angle, angle C was the larger angle, and angle A was the more acute angle. But the nice thing is now that they're all set up this way, we can very quickly and easily set up proportions to find corresponding parts. So for example, if I knew this is 10, and this is 15, and this is 6, and this is x, I could find and solve a proportion to find the value of x very, very quickly. Couldn't I? I mean, that's easy. 10 over 15 equals 6 over x. Very easy to do. So the real trick is going to be redrawing the triangles. And if we redraw and relabel our triangles and just get the right measurements in the right spots, setting up and solving these is going to be quick and easy. So here's a picture. I need to find x, y, and z given that these two parts are 4 and 12. And again, I'm going to label my vertices here. So I'm going to make my smallest angle A out here, make this B, this C, and this D. So what I'm going to do is this. I'm going to draw three very distinct triangles: the Papa triangle, the Mama triangle, and the Baby triangle. Set them all up so their right angle is right down there. The smallest angle is always at the top. It's all set up exactly the same way. Now let's start with the Papa triangle. The Papa triangle is the big outer triangle. The big outer triangle here, the hypotenuse is 12 plus 4, or 16. The long leg of that big triangle is Z, and the short leg is X. In the Mama triangle, that'd be this one. Okay, there's my right angle. My right angle there is D. Doesn't matter for that. I know the hypotenuse is Z. The long leg is 12, and the short leg is Y. Then in the Baby triangle, little baby triangle down here. Ooh, that purple became red. That's cool. Okay, my right angle's right there. My hypotenuse is X. My shortest side is 4, and my middle side is Y. And now I can try to start setting up some proportions. You're saying, well, wait a minute here. I'm a little bit stuck because I don't see where my proportions are right away, because I don't have any two corresponding sides I know the same length of both times. That's true. So let's just see what we can do. Z goes with 12, so Z over 12, corresponding parts, this Z and this 12, goes with 16 over Z. There's a proportion that's set up, but it only has one variable. Oh, so I can cross multiply that. Z squared equals 16 times 12. 16 times 12, which I should know over the top of my head, but I'm just brain stinking today. So 192. And I can solve that. Take the square root of both sides. Z equals the square root of 192. Now, I do have to simplify the square root of 192. Let's see. 192 divided by, I think, 64 goes into that, doesn't it? Yeah. But there it is. I've now found that Z is the square root of 192, or 8 root 3. Okay. Now that I have that, now I can start figuring out how long X and Y are using Pythagorean theorem. And once I have X and Y, I'm all good. Now I have these triangles drawn out. Because I know two sides of my right triangle, I can easily find the third using Pythagorean theorem. No two sides, find the third using Pythagorean theorem. That's what we're going to be practicing. This is what we're going to be working on today. So the actual theorem in the book here breaks it down this way. It says right triangle similarity. If the altitude is drawn, the hypotenuse of a right triangle, the two triangles formed are similar to the original triangle and to each other. It's exactly what we've been talking about. And now I'm going to give you a little chance to practice. Now I'm going to help you a little bit. We're going to set up this first one quite well. We're going to look just for X. So I'm going to draw my three triangles: Papa triangle, Mama triangle, Baby triangle. Okay, set them all the same way. Clearly indicate the right angle. In the Papa triangle, the big Papa triangle, hypotenuse is 5, the short leg is 3, and the longer leg is 4. It's all twisted and flipped around. That's okay. In the medium triangle, which is this one right here, here's my right angle is right there, so the hypotenuse is 4. The short leg is X, and the long leg we don't know. There's nothing there. We're just going to leave that blank. In the baby triangle, this one over here, the hypotenuse is 3. The short leg we don't know, but the medium leg is X. I have to use one of these situations to solve for X. I could either use the big triangle and the pop and the mama triangle, the big and the middle triangle, or the big and the small triangle, set up and solve a proportion. That's your first problem. Second triangle. Again, start out by doing the same thing. Draw your papa triangle, your mama triangle, and your baby triangle. And again, I'm just kind of bringing up Goldilocks and the 3 bears here, just for fun. And start labeling. In the papa triangle, the hypotenuse is 13. The long leg, or the short leg, the shortest side is 5, the medium side is 12. Now you set up the mama and the baby triangle, and this time you solve. That's pretty much the end of our podcast, and we'll be working on this today and tomorrow. This is kind of interesting stuff, but if you take the time to draw it out and work carefully, I think you can get this pretty quickly.